Okay. Graphs of polynomials. You have your zeros. You have your y-intercept. Okay? And if that's all you have, well, you might not know exactly how the graph is going to work out. Could be like this. Oh, no, can't do that. Why not? What's the next point I've got to go through?
The y-intercept.
Well, why can't I go through the y-intercept now?
Because you'll cross over the x-axis again.
I'm sorry, really?
You'll cross over the x-axis again to go up.
Yeah, to get back there, I've got to go through the x-axis, don't I? Well, I can't go through the x-axis between here and here because there are no zeros. Okay? So, nope. Can't get back. To the y-intercept. There are no zeros here. Does that make sense? No zeros between here and here. Okay? So if we're going to come down from over here, what do we have to do? We can still come down from here. If we've determined that the polynomial has to have positive values all the way on this side of the zero, then we know we have to come down from here. Well, we can do that. We just can't go through the x-axis at this point. Okay? Then we come up here and go through the y-intercept. We can come down here, and then we come back up here. Now we don't know anything else, but if we know whether the function goes up or down over here, then we know whether we go through this zero or just touch this zero and go back down, right? So assuming the graph does this, then we can do this sort of thing. Does that make sense? Okay? So we know that, and most of your graphs of polynomials look pretty good. But some of them stop here and here. Okay? You just go from here to here. Well, a polynomial is defined for all values of x. Its domain is negative infinity to infinity because all powers of x can be evaluated for any number at all, right? So you can find all the powers, you can add them up, multiply by things, okay? So any number from negative infinity to infinity works. Now the question then becomes, how do we determine whether it goes up here and up there? Okay? Well, it's pretty easy. There's a simple rule for it, but we need to understand why that rule applies, okay? So, let's consider okay? And what we want to look at now is what we call end behavior. Okay? going to say what happens at points far to the right of x equals 5 and far to the left of x equals -4. And why do I say far to the right of x equals 5? Well, what are the zeros? What values of x make this polynomial 0?
3.
3 will make it 0 because 3 minus 3 is 0. When you multiply that by the rest, it's going to give you 0. Okay, that's good. Somebody give me another one.
-4.
Pardon?
-4.
-4. So that's going to make this 0, right? And somebody's going to tell me 5. Who wants to tell me 5?
5.
Good. Thank you, Grace. Okay. Right? Make sense? Well, in order, that would be -4, 3, 5. So -4 is the one furthest to the left, and you're going to, if you're to the left of -4, then you're to the left of all the zeros, right? And if you're to the right of 5, you're to the right of all the zeros. And if you're far to the left of -4, well, you're far to the left of all the zeros. Okay? So, if x is 1,000, that'd be far to the right of x equals 5, right? What's x minus 3? 1,000 minus 3.
997.
Pretty close to 1,000, isn't it? Doesn't differ from 1,000 by a whole lot. Only 0.3% less than 1,000, right? And x plus 4 is pretty close to 1,000, and x minus 5 is pretty close to 1,000, right? So is this positive or negative for big X?
Positive.
Yeah. If you're far to the right of x equals 5, then all these are positive, okay? Okay, so we can reason out. All the factors are positive and large, right? So P of x is going to be the product of 4 large positive numbers. What do you get if you multiply together 4 large positive numbers?
Even bigger positive number.
You get a really humongous positive number, okay? Right? So what does it look like? Where on a graph would the corresponding point be? X is going to be a large positive number, right? It's going to be out there somewhere. Okay? Y is going to be a humongous positive number. So in what direction do I have to go to get out to a point where you've got a large positive number and a humongous positive number for your x and y coordinates? You've got to go way up, right? So that's what the graph does. Okay? Make sense? Now, far to the left of x equals -4, dot, dot, dot. You get a product of 4 large negative numbers, right? And it's going to be this and 2 of these, right? An x plus 4 and an x plus 4. So you got 4 numbers there, right? You actually only have 3 numbers, but you got one of them twice, right? Which is why I say there are 4. Okay? Well, what can you tell me about the product of 4 large negative numbers?
It's another large positive number.
Yeah, could be a humongous positive number. So, well, now you're going to large negative number and a humongous positive number. It'll be up there. So that's why you would come down from up here, like we did. Now this is not an exact picture of this, okay? If I had, let's just replace that x minus 3 by x minus 1, okay? Doesn't change the truth of anything we just said. Okay, our biggest, our rightmost 0 will be at 5, and our leftmost will still be at -4, right? And also, we go through the -4, the 0 at -4, we can't go down through it because our y-intercept is positive. How do we know the y-intercept is positive? Well, if you plug in 0, you have -1 times 4 squared times -5, right? That's a negative, 2 positives, and a negative. It's going to give you a positive, right? So we don't know how far up or down it is, but this is a reasonable picture of what that polynomial might look like. Okay? So we better have a square on this one, so it'll do this. Now, why does a square make it do this? Well, I'm going to ask you to reason through a little of that for homework, but just because near x equals -4, this acts a lot like the y equals x squared polynomial. It's a square. Makes sense that it, for some reason or another, we'll try to get to, does this sort of thing, right? And we talked about this already, okay? But, yeah, just didn't emphasize it a whole lot, so if you didn't pick it up, well, pick it up next time, review the notes and stuff, okay? Okay, so, we get that idea? It's pretty simple picture, and we've looked at it a few times. First I asked you just to draw a nice smooth curve that goes through a bunch of zeros, right? Then I asked you a little more, and then I made it a little trickier, and there it is. Okay? And the last thing you got to know is how to reason out what happens over here and what happens over here, which is really quite easy. All you got to do is follow the same procedure. Now, when you do, and I expect you to use the same kind of words I use. On the test, most people were not using rate of change terminology to analyze the meanings of fundamental triangles. Okay? I certainly emphasized it. I certainly used it consistently, right? But most of you didn't do that. Okay? Why didn't you do it? Because you missed it. Okay? Then you missed it when I told you about it, and you missed it when I told you about it. Okay? I don't think you would have missed it if you'd been reviewing the notes. Okay? So we got to start doing that. Now, get off camera here and talk about this a little bit. I'll do it in camera, but different topic.